Saxon Algebra Test 17. Number 1 is from Lesson 84, and it says a penny is dropped from a 512-foot tower. The equation below can be used to find the height, h, of the penny after falling for t seconds. Estimate the height of the penny after falling for 2 seconds. So really, this one is just plugging in a number into an equation using your order of operations and solving. So we know that t stands for seconds, and we want to estimate the height of the penny after falling for 2 seconds. So that means we need to plug this 2 into our t, since t represents seconds. So I'm going to rewrite the equation. We have 512 minus h equals 16, and then we're going to plug in a 2 for the t and square that. So I'm going to simplify the right side first, and order of operations we have to do exponents first. So 2 squared is 4, and 16. And then we just have the same thing over here on the left. We can't simplify that. And then on the right-hand side, we can simplify again. 16 times 4, which is 64. And again, same thing, still left on the left side. But now we want to solve for h. So I'm going to subtract 512 from both sides. So on the left, I have negative h equals negative 448. I'm going to rewrite that up here just so I have some more space. So that was negative h equals negative 448. Now remember, we don't want to leave it like this because that's really a negative 1 that's in front of that h, and we don't want a negative number in front. So we're going to divide both sides by a negative 1. Those cancel. So h equals a positive 448. And we're talking about height, and it was in feet. So our answer is going to be 448 feet. Number 2, it says determine whether the side lengths below perform a Pythagorean triple. So you could easily just take these and plug them into our Pythagorean theorem and see if it works. So remember, our Pythagorean theorem is a squared plus b squared equals c squared. And c is always our hypotenuse and our biggest side. So I know c is going to be our biggest number, which is 26 squared. And then the a and the b, it doesn't matter which order you put these two numbers in. You could put the 10 first or the 24 first, it doesn't matter. So I'm just going to do 10 squared plus 24 squared. So 10 squared is 100 plus 24 squared is 576. And 26 squared is 676. So now on the left side, we're going to add 100 plus 576, and that's 676 equals 676. So since that is true, we would say yes, these do form a Pythagorean triple. Simplify. So this one is just a distributive problem, but we're just dealing with some radical signs in it. So first we're going to do root 3 times 2. So that's 2 root 3 plus, and now we have root 3 times root 6, and that is root 18. Now, 2 root 3 cannot be reduced because you can't break down 3 into any other factors, but we could break down 18. 18 we can break down into 9 times 2. I'm going to rewrite all this. And we know that 9 is a perfect square, and that's 3. So that means we can pull a 3 out, and we're just left with that 2 on the inside. And then we have the 2 root 3 over here. Now, neither one of these radicals can be simplified, but they can't be combined either because one is a root 3 and one's a root 2. So therefore, we can't go any further, and that's our final answer. Number 4 is from lesson 58, and they want us to simplify. So a couple ways you could do this. I'm going to do it where I just take each one of these values, those two monomials from the binomial, and multiply them by each of these. So you're basically just taking this 2x and distributing it to every single thing over here, and then I'm going to do the same thing with the 4. So let's start. We have 2x times negative 3x squared. That's going to be negative 6x to the third. Then we have 2x times 5x, so that is 10x squared. And then 2x times 3 is 6x. Now we're going to do the same thing with the 4. So we have 4 times negative 3x squared. That's negative 12x squared. And then 4 times 5x is going to be 20x. And then 4 times 3 is 12. So now let's go and look and see if we can combine any like terms. So first I notice we have an x cubed here, but there's no other x cubed. So nothing can be combined with that. So it just remains negative 6x cubed. Then I have an x squared and I have an x squared over here. And notice there is a subtraction sign in front of there, so if it helps, do your add a line, change a sign. So we can clearly see it's a 10x squared plus a negative 12x squared. So that's going to be a negative 2x squared. Then I have an x to the first power and another x to the first power. And that's just 6x plus 20x. So that's plus 26x. And then last but not least, we have just this constant 12. So plus 12. And that is the final answer. Number 5 is from lesson 61, and they want us to simplify. So one way you can do this is just write out the prime factorization of everything. So 9, we have 3 times 3. S to the 4th, that means there are 4 s's. And then there are 5 t's. All right, so now we go look for our pairs. So we have a pair of 3's, so that means a 3 comes out. We have 2 pairs of s's, so that means we're going to have s squared. And then we have a pair of t's here, a pair of t's here, so that's 2 pairs of t's. And then we just have this lone t that's going to be left inside. And that's it. Number 6 from lesson 56. Tell whether the set of ordered pair below represents a direct variation. If the set of ordered pair does represent a direct variation, find the constant of variation. So the easiest way to do this is to just plug everything into our direct variation equation, which is y equals kx, and see if we get the same thing for k on all of them. So let's do our first one. We're going to plug in negative 15 for y equals k times 3. If we divide both sides by 3, we get k equals negative 5. Now let's do the second one. We have 10 equals k times -2. We divide both sides by -2. We get k equals -5. And then last, if we have the last one is 20 equals k times -4. Divide by -4 on both sides, and we get k equals -5. So notice that they all have the same k. So we would say that yes, this is direct variation, and the constant of variation is -5. Determine whether the lines are parallel. So remember, if two lines are parallel, they have the exact same slope. Line 1 is already written in slope-intercept form, so we can clearly see the slope is 3/5, or 3/5. Line 2 is not in slope-intercept form yet, but we can easily fix that by solving for y. So I'm going to subtract 10x. We have -6y equals -10x plus 18. Then I divide everything by -6. And so we get, I'm going to write the final answer up here, y equals 10/6x minus 3, because 18/6 would be a -3. The 10/6 we can reduce. We can divide both of those by 2 and get 5/3 x minus 3. So here's the slope of our second line, and here's the slope of our first. They are not identical, so therefore, no, they are not parallel. Number 8 from lesson 79, it wants us to factor this trinomial. So first thing I notice is all of these are even numbers and they all have an x. So I first want to factor out the GCF. So I'm going to factor out a -2x, and I'm left with x squared plus 2x minus 8. And if you're unsure about the signs, if you multiply this -2x back into all these numbers, you just want to make sure you get back what you had originally. So for instance, -2 times this would give us a -2x cubed. -2 times a +2x would give us that -4x squared. And then a -2x times a -8 would give us that +16. So it's good just to double check and make sure you got all the right signs left over once you pulled out a negative number. So now I have this -2x on the outside, but I can factor this trinomial. So remember, we make our x, we have -8, and then 2. So we need to think of two numbers multiplied together would give us a -8, added together give us a +2. So I am guessing we have 4 and 2, and we know one of them has to be negative because when they multiply together it's a -8. However, when we add together we get a +2. So therefore the bigger number must be positive and the smaller number must be negative. So here are our two numbers, and that's what we're going to use to write our two binomials once we factor. So we have -2x squared, parenthesis, x plus 4, and x minus 2. And that is your final answer. On a test, I would definitely take the time to check this, and you can check your answer by foiling the two binomials. So if we FOIL the two binomials, we get x squared minus 2x plus 4x minus 8. And we still have this -2x out here. And then when we combine our middle numbers, we get x squared plus 2x minus 8, close parenthesis, -2x. And notice that this is exactly the same as that. So therefore, this is we did factor it correctly, and that's our final answer. Number 9, factor the trinomial. So notice this one is we have two variables in it, but that's not a big deal. We just still factor it the same way. So I always look at what our last number is and our middle number and make the x. So 8 and 6. So the two numbers that I'm going to use would be 4 and 2, because 4 times 2 is 8, but 4 times 2, or 4 plus 2 is 6. Now the only thing is when you have this y in here too, is your second number in your binomial is just going to have that y with it, that second variable. And that's your final answer, but of course on a test, make sure you check. So we're going to FOIL it. X times x is x squared. X times 2y is 2xy. 4y times x is 4xy. And then last, 4y times 2y is 8y squared. We can combine these two middle terms to give us x squared plus 6xy plus 8y. And that's correct. So we know then that this was the correct answer. Number 10, factor the trinomial. So looking at this, there are a couple things. One is it's not written in descending order, and two, they're all even numbers, so I know I can factor out a 2. So first thing I'm going to do is write it so it's in descending order. So we're going to have 8x squared minus 22x plus 12. All right, so now it's in the correct order. And now I'm going to factor out a 2 because they're all even numbers, so I can definitely factor out a 2. That's the GCF. And I'm left with 4x squared minus 11x plus 6. All right, so now since this is one of the trinomials that has a number other than 1 out in the front, we can use that other technique that I've done before where we still make our x, but the number that goes on the top is your last number and your first number multiplied together, so 24. And the middle number is still negative 11. So now I need to think of two numbers multiplied together would give me a 24, added together would give me a negative 11. And the first thing I thought of is 8 and 3. But we know that added together they needs to be a negative, and multiplied together it's a positive, so they must both be negatives. So negative 8 times negative 3 is a positive 24, but if I added them together, that is a negative 11. So these are the correct numbers. And when I do this, I still have this 2 hanging out here. I'm just going to kind of leave that there. And I rewrite the problem, except now instead of writing our middle term, I write our middle term using these two new numbers. So minus 8x minus 3x. Because minus 8x minus 3x does equal negative 11x. So it's the same thing, just written differently. And then plus 6. I'm going to erase this so I have some more room off to the side in a second. Okay, so now I separate these into two binomials. So now I need to factor each binomial. So this 2 right here, I'm just going to circle to kind of remember that I need to write that in my final answer. But I'm first going to focus on this first binomial. 4x squared minus 8x. I can pull out a 4x, and I would be left with x minus 2. Over on the other side, remember that this binomial has to match whatever's going to be left over once I factor this other binomial. So I like to write it down sometimes and just work backwards. So I have to think, well, in order to have this left over, what must I have pulled out? And it must have been a negative 3, because this is where I work backwards. Negative 3 times x would give me this negative 3x. Negative 3 times negative 2 would give me this positive 6. So my answer then, I'm going to write it up here, is one of the binomials is always the one that's the duplicate, so x minus 2. And then the other binomial is made up of the two things we pulled out. So 4x minus 3. And then remember we circled this 2 earlier. That's to remind us that we had to put that 2 out right in front. And remember, you can always check your answer by foiling the two binomials and then multiplying that new trinomial by 2 and make sure you get this original problem. Number 11 is from lesson 77. Jim borrows $95 from his parents. They agree to subtract $10 from the loan for each hour he does chores around the house. To find the number of hours X he needs to do chores before he owes less than $50, solve the inequality. So they've already set up the inequality for us, so all we need to do is just solve it now. So we want to solve for X because that's going to tell us how many hours he needs to work. So we're going to subtract 95, get rid of that on this side. We're left with negative 10x is less than negative 45. And then we divide by negative 10. So we get x is less than, that's going to be a positive 4.5. So he needs to work less than 4.5 hours before he owes less than $50. Number 12, lesson 83. Determine whether the polynomial below is a perfect square trinomial. If it is, factor the trinomial. So if you remember, a perfect square trinomial follows this pattern, where you have a plus b squared, and when you factor it into a perfect square trinomial, it falls into the pattern of your first number squared plus 2 times a times b, so the two numbers multiplied together, plus your last term squared. So let's see if we can figure out if that works with this trinomial. So first, it looks like what we need to find what our original a and b would have been. So this number before it was squared and this number before it was squared. So x squared would have just been x, and this number would have been 4. So we can rewrite that as x squared and 4 squared plus 2, and this is our a, and this is our b, so times x times 4. And if we multiplied this out, we would get 8x. So it looks like it does fall into that pattern. So this is a perfect square trinomial. And if you can recognize that it's a perfect square trinomial, you don't even have to FOIL. You can just know that if your a is x and your b is 4, it's just x plus 4 squared. Now, if you didn't realize this was a perfect square trinomial and you had to factor it, of course you can just use the old method. It's a little bit longer, but it works nonetheless, where you make your x and you have 16 up here, 8 here, and you find two numbers, multiplied together give you 16, added together give you 8, and that's 4 and 4. So that means we have x plus 4 and the exact same thing, x plus 4. So you would write that simplified as x plus 4 squared, since there's two of them. Number 13 from lesson 80. Suppose that 7 cards each contain one letter from the word raccoon. Make a bar graph to represent the frequency distribution for all possible outcomes. Find the theoretical probability of each outcome. So we have to make a bar graph first. So the things we're comparing are the letters in raccoon. So we have an R, there's an A, there's a C, an O, and an N. And notice there's not that many letters, so I'm just going to go up by single numbers. So 1, 2, 3, 4. Okay, there is only one R, one A, there are 2 C's, 2 O's, and only one N. So there's our bar graph. That's the first part of the problem. Next is finding the theoretical probability of each outcome. So let's start with R. The probability of getting an R. There are 7 letters total in raccoon, and there's only one R, so that's 1/7. The probability of A, again, is only 1/7 because there's only one A. Probability of C, this is going to be 2/7 because there are 2 C's. The probability of O is again 2/7. And last but not least, the probability of N, there's only one, so 1/7. And there's your probability for all the different letters. Number 14 is from lesson 78, and they want us to identify the asymptotes and graph the function below. So if you recall, the vertical asymptote is basically just your excluded value. So remember, we find excluded values by taking the denominator and setting it equal to 0. Subtract 3, and x equals -3. So our vertical asymptote is x equals -3. Our vertical asymptote is if there's ever a number that is added or subtracted onto the end of an equation like this. Now, if you look at this problem, there isn't anything. There's nothing being added or subtracted onto the end. So therefore, the horizontal asymptote is 0 because there's nothing there. So we would say y equals 0. So, for example, if you had y equals 4 over x plus 3 minus 2, your horizontal asymptote would have been -2. So just in case there's a problem like that where there is one, you can recognize what that is. But in this case, we don't have anything. So we are going to have to graph this. So I'm going to go ahead and draw my graph and draw in the asymptotes. And you always draw those with a dotted line. So we have x at -3. So let's go to -3. And we're going to draw a dotted line. And we're going to draw a dotted line right there. And then we have y at 0. Well, that's just basically our x graph. Well, that's just our x-axis. So we don't really need to draw dotted lines, but I'll just kind of put it right there so you can see I drew it right there. All right, now we have to graph this. So this is just like we used to do where we make an XY table. And I like to be kind of strategic about the x's I choose so that it doesn't turn into like a funky fraction. So for example, I could choose maybe -5, because a -5 plus a +3 will give me a 2, which is divisible by 4. Or 4 is divisible by 2. And maybe I'll do a -4, do a -2, a 0, and then I'll do a 1, a 5, and I'll just leave it at that. So let's see if that gives us enough. So we have -5, so let's start there. So 4, -5 plus 3, that's 4 over -2, or -2. So let's go plot that point, -5, -2. So we are going to go, that's -3, so here's -4, -5, so you go out a little bit further, and then down to -2, so about right there. There's one of our spots. Now let's plug in -4. So -4 plus 3, that's 4 over -1, or -4. So we have -4, -4. So here's our -4, and then we'll go down 4, about right there. And then we have -2, so we'll plug in -2 plus 3, and that equals 4 over positive 1, which is 4. So we have negative 2, positive 4. So we go back 2, but this time we go up 4. Oops, I didn't mean to do that in green, but oh well. Now let's plug in 0. 0 plus 3 is 4/3, and that's kind of an ugly one, but that's okay. We'll have just one like that. So 0 and 1 1/3. So x is 0, and then this is just a little bit above the 1, so about right there. Now we have 1 plus 3, which is 4 over 4, or just 1. So we have 1, 1, which is like right there. Oops. And then our last one that we chose is 5. So we have 5 plus 3, which is 4/8, which again is a fraction, but it's kind of an easier one to recognize. So 1/2. So we have, when x is 5, y is 1 1/2. So just 1/2. So just right about there. I'll make that green since I started the green thing. Now these graphs, they connect, and remember they always come very close to reaching the asymptotes, but never quite touch it. And so this one over here, we didn't get a lot of points for the it, but we know just kind of based on these 2 points, it's going to get really close down here, and then really close and kind of go off to the side right there with that one. And there's your graph. Solve the disjunction. So we have to solve each of these equations, each of these inequalities, and then graph them on a number line. So let's start over here with 3x plus 2 is less than 8. I'm going to subtract 2 from both sides. So we have 3x is less than 6. Divide by both sides by 3 to get x is less than 2. And then we have or. Now let's solve this side. We have 2x minus 5 is greater than or equal to 5. We'll add 5 to both sides to get 2x is greater than or equal to 10. Divide both sides by 2, and we get x is greater than or equal to 5. So here are our 2 solved problems. But now I'm going to erase just this side so I have room for a number line. We need to graph this. Now this is a disjunction or an or problem, so I already know that my arrows are going to be pointing in opposite directions. So we have 0, 1, 2, 3, 4, 5, 7, 8. So let's look at this one first. X is less than 2. So it's going to be an open circle on 2. And the arrow pointing to the left because it's all the numbers less than it. Over here we have x is greater than or equal to 5, so that means it's a closed circle because of that equal sign. And it's all the numbers greater than 5. So it's going to be pointing that way. And that's it. Okay, subtract. Now, just looking at this, we can't subtract how it is because the radical signs are different, and so they're not like terms. However, we can simplify these. So if I'm looking at the first one, I know that 12, one of its factors is a perfect square, which is 4. So I'm going to rewrite 12 as 4 times 3, and then we have our a. Since 4 is a perfect square, that's a 2. We can pull a 2 out. So we have a 2a out. But this 3 doesn't have a pair and the a doesn't have a pair. So they have to stay inside. Now let's move over to this one. Now you could find the prime factorization of 48, or if you already know one of the factors of 48 that's a perfect square, you can just jump straight to that point. So I know that 16 times 3 equals 48, and 16 is a perfect square. And then I have 3 a's. So this is a perfect square, that's a 4, so I'm going to pull that out. And then we have a pair of a's, so I can pull an a out. And then I'm left with 3a. So now we have like terms and we can add these. So if you want to, you can add a line, change the sign. So we really have a 2a plus a negative 4a. So that's negative 2a root 3a. 17, if y varies inversely as x and y equals 8 when x equals 6, find x when y is 4. Now remember, there's two ways to do inverse variation. First way is to use your formula. And we first have to solve for k, because notice they give us y and x. So they give us everything but k. So we'll plug in 8 for y equals k over 6. We're going to multiply both sides by 6 over 1. Those cancel. We're left with k equals 48. So now that we know what k equals, we can go and plug it in to our inverse formula. So we have 48. And we're trying to find x when we know y is 4. So I'm going to plug in 4 for y, but we don't know what x is yet. So I'm going to multiply both sides by x because those will cancel. So we have 48 equals 4x. Divide both sides by 4 and we get x equals 12. Another way to solve inverse variation is to multiply your first x times your first y and set it equal to the product of your second x and your second y. So our first xy pair were 6 and 8. So 6 and 8. And our second xy pair, well, we know y was 4, but we don't know what x was. So we have 48 equals, I'm going to rewrite that as 4x. Divide both sides by 4. And you get x equals 12. Exact same answer, just another way to do it. Okay, next one. Write the polynomial below in standard form, then write the leading coefficient. So standard form is when you have the exponents written in descending order. So that means I need to take my term with the highest exponent, which is this one, and it needs to go first. Then I would have 4a squared, and then 2a. So that's written in standard form. And now the leading coefficient is the number that's written in front of your first term. Now, we usually don't write it, but we know that there's a 1 there. So our leading coefficient, I'm just going to abbreviate that, is 1. So I can erase that. So this is your answer. Okay, number 19. From lesson 81, solve the inequality and graph on a number line. So this is just like any other inequality, except we have variables on both sides. So if I can, I always try to get my variables on the left. So I'm going to add 4x over to the left side. So we have 7x plus 2 is greater than negative 12. Then I subtract 2. So I have 7x is greater than negative 12 minus 2. And remember, you can always think of that as plus a negative. So it's really negative 12 plus a negative 2, which is negative 14. Divide both sides by 7, and we get x is greater than negative 2. So now we need to graph this. So I'm going to make some space here for a number line. So we have 0, here's our negative 2, positive 2. So we know it's an open circle around negative 2. And then if you look, it looks like the arrow is pointing, or the inequality sign is pointing to the right. That's a clue that you're going to point it this way. But it also just makes sense too, because we're saying any number greater than negative 2 is going to be an answer. So we want to make sure we show everything greater than negative 2. Number 20 from lesson 82, solve and graph. So this is a compound, multi-step compound inequality. So the first thing I want to do is simplify the middle part, because notice we have a 4x and a 2x, and those can be combined. So I'm going to rewrite this part, but I'm going to combine that to 6x minus 2 is less than or equal to 10. Now we're trying to get x by itself in the middle. So to do that, I need to get rid of the 2. So I'm going to add 2, but I'm going to add it to both sides of the inequality. So on the left, I have negative 6 is less than or equal to 6x is less than or equal to 12. Now I need to divide everything by 6. So I am left with, I'm going to write it right over here so I have plenty of room. In the middle is just x because our 6 is canceled. And on the right, 12 divided by 6 gives me 2. And on the left, negative 6 divided by 6 is negative 1. So there is part of my answer, but I also have to graph this. So let me erase some of this to make room for a graph. Okay, so I know I need to have a negative 1, 0, and there's my 2. Let's do a few more. So they're both going to be closed circles. And notice, let's focus on this one first. X is greater than or equal to negative 1. So that means I want all the values greater than negative 1. However, over here, x is less than or equal to 2. So that means I want all the values less than 2. So this is the area that they have in common, and that is your graph.